Okay. Well, hello, and thanks for joining me today in this webinar. My name is Alessandro Falgarcia, Technical Marketing Engineer at NGINX, and I'm here to tell you everything you need to know to go from zero to hero in the world of APIs and API gateways. So let me first go over the agenda real quick. I'm going to start by going over the basics of an API, then cover what are some of the key features all APIs should implement, and then move on to covering how API gateways help you build digital experiences. Once we cover all that, I'll show you how and why you should consider deploying NGINX as an API gateway, and then give you a brief overview on how NGINX App Protect can help you secure your APIs. Finally, if everything goes according to plan, I'll be giving a live demo showing how to deploy and secure an API gateway using NGINX and NGINX App Protect. And you can find the link to the demo on the site here. It's a public repository in GitHub, so feel free to clone it, download it, play along with it, and whatnot. So with that out of the way, let's get to it. What is an API, or a REST API more so? Well, let me use an analogy to explain it. And to do that, let's go back in time. Back in the good old days, we as humans had to learn how to hunt and consume our prey, animals in this case. And to do that, we developed tools such as the access you can see these guys are using. Or to put it a slightly different way, we could think of us, the consumers, trying to get access to data to be consumed. And where our ancestors had access, we've developed APIs to help us consume all of that data. But I still haven't really explained what an API is, have I? Let me Google that for you. An API, or an application programming interface, according to Google, is the set of functions and procedures allowing the creation of applications that access the features or data of an operating system, application, or other service. Or, in simple terms, there are a set of dedicated URLs that are optimized to return the pure data to requesting clients. So the same way you have a web client or a web browser, such as Chrome, making a request to a web server, which in turn returns some HTML data, and that's what you see in your browser, that's the website you're looking at. You can have an API client making a request to an API endpoint, which in turn returns some pure data. Now, of course, the API endpoint is only one of the many components of an API. You also need to specify the API method, which declares which type of operation you want to conduct on the API. The API request body, if you're sending data to the API. And finally, of course, you need an API client, which is where the API request originates from. It can be curl if you're using a terminal, it can be Postman if you're using that tool, it could be any number of client applications, etc. And for a more visual representation, you can see how you have the API client there on the left side. The API client sends a request via the internet to any number of APIs. The APIs then return the data over the internet back to your client. And as part of that request, you have your API method and your request body, assuming, of course, as I said before, that you're sending some data. And just to give a quick example of a real-life API, which you can actually just go and query yourself if you so wish, here's a Pokemon API that I queried earlier to find out the type of Pikachu, which, as you can see, happens to be electric, if you didn't know. As you can see also, the response is given in the JSON data format, which happens to be the standard language for modern APIs. In this specific scenario, curl is the API client, get is the API method. There is no request body because I'm not sending any data. I am just requesting data in this case. And Poke API is the API endpoint. So now that we've covered the basics behind what an API is and how it looks in practice, let's delve a little bit deeper into some of the API fundamentals that are behind the adoption of APIs and what users and developers expect from those APIs. So what are some of the drivers that are making APIs grow exponentially in popularity? Well, first, there's the fact that APIs help unlock data by using access to information. You can let your users or customers easily build integrations on your product, or you can improve cross-team data sharing and collaboration. Second, APIs play a key role in the microservices world, with APIs enabling microservice components to seamlessly communicate between each other. APIs are simple and fast to develop and maintain. They provide a good fault isolation and resiliency and enable apps to scale easily. And finally, APIs also provide new opportunities to generate revenue and build partnerships with third-party developers. You can expose your APIs and perhaps create a digital marketplace for an enterprise. And indeed, some of the larger companies out there, such as PayPal or Expedia, companies that you surely have heard about, are based around the revenue model, monetizing their public-facing APIs. And given the importance of those drivers for API adoption, it makes sense that out of 57% of businesses undergoing a digital expansion at the moment, 58% are doing so by adding a layer of APIs to enable modern user interfaces. And indeed, according to Programmable Web, a leading source of news and information around internet-based APIs, since January 2015, an average of more than 2,000 APIs have been created per year. So now that we've covered why APIs are growing in popularity, let's delve a little bit more into what people, in this case users and consumers, expect from APIs. Well, first and foremost, there's ease of use. If you're using an API, you want it to be easy to use, easy to understand, and have a relatively low complexity level to get running. You want the API to have a low latency and be highly performant so that whenever you query the API, you'll get your data back within microseconds or milliseconds. You want the API to be secure because no one likes their potentially sensitive data to be exposed or, intercepted through the internet. And finally, you want good documentation. That speaks for itself. If you've used any piece of software or any product in the past, having good docs makes it way simpler and way faster to get up and running and interact with the product, or in this case, the API. On the other side, if you are an API owner or a developer, or your business/product depends on APIs, you want an API that lets you grow your revenue, whether it's via monetization or improving your brand awareness. You want an API that provides a good user experience, an API with solid docs, like I mentioned earlier, if you're a user, and an API that has a low latency that makes users come back to it over and over again. You want an API to solve around solid, an API that protects your users' data and keeps confidential data confidential while performing 24/7. Downtime is usually not good for any product, any brand, any company. Same thing happens from the API side of things. And finally, you want an API that's easy to develop and maintain so that you can keep improving it over time. An API with a simple configuration language that can be integrated into your CI/CD pipelines if needs to be. So how do we guarantee that both those customer/user and owner/developer needs are met to deliver mission-critical digital experiences? Well, that's where API gateways come into place. Let's go back to the lifecycle diagram I shared earlier. At first glance, this looks like a simple workflow. API client sends a request to the internet, request reaches the API endpoint, and the data is returned. And like I also briefly touched upon before, it's somewhat similar to how a web browser works. When you send a request to a website, it's hosted on a web server returns some HTML or JavaScript data through the internet back to your API client. And if this were actually a web server use case, we could place a load balancer or reverse proxy in front of the web server to improve its performance. Well, it turns out we can do something similar with APIs. That is, you can place an API gateway between your internet layer and your API layer. With an API gateway, you can easily enable some features for your API, such as authentication to only let certain users into your API, request routing. If you have multiple API endpoints, maybe each API endpoint lives within a different microservice. Traffic control, maybe your API lives in a relatively low capacity service or microservice, and you want to make sure that it stays readily available by limiting how many people can access it at some stage. Or for example, you can also enable some level of exception handling, make sure that if the API is not responding for some reason or another, you still return some useful data or a useful error message back to your client. But those are not the only functions expected out of an API gateway these days. API gateways have to also be capable of performing centralized logging, to have a centralized repository or a centralized text file or logs, obviously, where you can see what's going on with your API and who's trying to access it, client authentication and access control to make sure that only allowed users can enter or access your API and that they can only access the API endpoints that they're supposed to access. Load balancing, if you have multiple replicas of the same API endpoint. Rate limiting, as mentioned before, if you want to control the amount of traffic going into any given service for whatever reason. Request routing, similarly, if you have multiple API endpoints, make sure that each query goes to the respective service. Request and response manipulation, if you have to transform some data, perhaps, maybe an API endpoint returns a lot of data, but the API client is actually only requested a fraction of that data. You can do that at the API endpoint level, or you can also do it at the API gateway level. Service discovery, assuming maybe you have multiple services that might scale up or down based on load. And TLS termination, if you want to enable encryption end-to-end from the API client down to the API endpoint. And an API gateway has to be able to do all of these things while ideally maintaining a real-time performance, which here at NGINX we tend to define as being able to process an API request end-to-end in under 30 milliseconds at the 99th percentile. But, if you deliver fast, responsive experiences, customers and clients will probably have to use their product, software, APIs, before choosing a similarly sluggish API experience. But are there any API gateways out there capable of this level of performance and this level of features? Now, given that, this is an NGINX webinar about API gateways and whatnot, I'm pretty sure you can see where I'm going to go with this. But the answer is yes, there is such an API gateway, and it is called NGINX Plus. After all, NGINX is well known and has become as famous as it has based on its highly performant reverse proxying and load balancing capabilities. And if you think about it, what is an API gateway if not an advanced reverse proxy? And furthermore, if you use NGINX Plus, NGINX's enterprise offering, you have access to state-of-the-art API features such as native JOT support. that, of course, for those of you that don't know, being JSON Web Tokens, which is the OpenID API authentication and authorization standard these days. And in fact, based on NGINX's latest community user survey, 30% of NGINX deployments are used as an API gateway. And why? Well, if there's one thing NGINX is known for, that's high performance, low latency proxying. This is a graph of a speed test I conducted with the GTest Golang speed test tool. And you can see that even at the 99.99% percentile, NGINX's API gateway latency does not really reach 10 milliseconds. One could say that NGINX is a highly performant engine comparable to those found in Formula One cars. So what are some other key strengths behind an NGINX Plus API gateway besides, high performance? Well, there's also the DevOps-friendly side of things. NGINX uses a configuration language that can be very easily integrated into your CI/CD pipelines, whether at a simple level, just by pushing your config files, or via third-party integrations with some configuration management language tools out there, such as Ansible. There's the fact that NGINX can be easily deployed into all major distributions. It's a simple software package, doesn't have that many requirements either, so it can be easily integrated into any CI/CD pipelines. And NGINX can also be deployed in high availability mode across multiple distributed environments and clouds. Furthermore, it can also easily interact with any API endpoints as long as network access is correctly set up. I also want to briefly touch on the fact that NGINX supports multiple authentication options, including the two most common API-related authentication options: API keys and JOT tokens. JOT tokens, as I mentioned earlier, only being available in NGINX Plus. And if you want to achieve the maximum level of security possible, you might want to give NGINX App Protect and its native API security capabilities a try. Because while properly implemented, authentication methods are all good and great, given the ever-increasing popularity of public-facing APIs, with Forrester's State of Application Security report indicating that 33% of apps have between like 3/4 of their APIs actually being public-facing, there's always a risk that some API might escape your grasp and be put in production and expose some sensitive data, or maybe even become a hacker's entry point to your whole infrastructure. NGINX App Protect's Web Application Firewall is a new natively built commercial module available for NGINX Plus, and it includes a neat feature to help secure those APIs that might have slipped your grasp. That feature being the ability to import and parse an OpenAPI spec file within NGINX and automatically create safeguards to block any requests that are not allowed by the OpenAPI spec. Instead of taking a reactive approach and blocking requests potentially identified as dangerous after the fact, NGINX App Protect lets you take a proactive approach and blocks all requests that are not explicitly identified as secure. And of course, you can deploy NGINX App Protect Web Application Firewall wherever you can deploy NGINX, given it's an NGINX Plus module at the end of the day, including, of course, within your NGINX API gateway deployment, if you so wish. And with that being covered, let's move on to a little live demo. Now, as I mentioned earlier, the demo is available at that GitHub link. There's a neat README and also a copy of the slides. Now, since it's a live demo, there's always a risk something will not work, which is why I am kind of apologizing just in advance with this little funny kitty. I have prepared backup sites should demo crash or whatnot, but let's give it a try. I need to change the screen I'm sharing. Okay, let's go do that. Hopefully that works. My Zoom sharing thing is in the way. Let's move it real quick somewhere it doesn't bother me. There we go. Can you stay there? Yes, you can. Okay, so I have deployed beforehand, before this webinar, 2 instances. I have an instance that's running NGINX Plus and NGINX Set Project. And then I have an instance that contains a simple Formula One API that's based on a very famous Formula One API called the Ergast Formula One API. Let's first check real quick that NGINX is running. That is running. The API should be running too if I query it. It's actually sportsdb. Marketing / API / F1. Okay, there it goes. There's a ton of data around here, but if I use GQ, you can see that it has quite a bit of Formula One related information. So now I want to set up my NGINX instance, which I'm currently SSH'd into, as an API gateway to my Formula One API. To do that, I have prepared a series of steps that you can see here. Sure, do that. Each step covers a very specific use case. So let's go step by step, actually. Start with sudo nginx-t, which shows you the default configuration for nginx. There's a server at port 80, and it returns the default nginx landing page. Okay, so now, well, for completeness, let's also query what's going to be my API endpoint. It's not going to work. It's going to be port 8080. There's nothing there, which is expanded again. So step 1 is defining my API endpoints, which I can do by creating a very simple server that's going to listen on port 8080. At this stage, I'm only defining my API endpoint, so I'm not actually going to be doing any proxying or any actual. I'm defining my API gateway entry point, so I'm not defining any API endpoints. So by default, I'm going to be returning a 400 error, just to make sure that the API gateway entry point is working, basically. Wait, let's see, right? I forgot to make Q executable. Okay, let's go. I have a little script that copies the files and reloads nginx and whatnot. That's basically what I just run. So let's scroll. Let's query that API gateway entry point right now. And I'm getting a 400 error response, which is to be expected. Now, this 400 error response uses HTML, which I touched upon earlier. It's not a, I mean, that's good for websites. It's not good for APIs. If you're using an API, you want, or if you're developing an API, you want everything to be written in JSON. So to do that, I'm gonna define a series of JSON error codes using the error page nginx directive, and that error page directive is going to redirect to named locations, which are going to return the respective error code in a JSON format. Let's go ahead and deploy step number 2. And now let's curl again, port 8080. You can see that I'm now getting the expected response. So also just check the headers just in case. Which is a 400 error message, but I'm getting it using JSON instead of HTML. Now, step number 3 will be to actually define the API endpoints that I want to query. and where my Formula One API database, for example, or API service actually lives at. So let's go ahead and check the files there. You'll see there's the API backends.conf file, which I'm not going to share, but this is where I'm defining my upstreams, or the Formula One API IPs. And then over here in my Formula One conf file is where I'm defining the actual reverse proxying capability of NGINX to each upstream Formula One API. Let's go ahead and deploy that one. And we can now try to query and find out, I don't know, some driver data. Let's see, F1 drivers. Let's see if Hamilton works. It is not working. Probably something went wrong. Okay, that is unexpected. Give me a second. QLD, live demo. Troubles that one never expects, but always end up happening. I must be missing something. Oh, my screen sharing is paused. Huh. She'll be able to go back to that in a second. Okay, she'll be back to working. Oh, I see. Yeah, out of practice, I just wrote HTTPS instead of HTTP. Oh well. As you can see, it is actually working if I create the right endpoint. Okay, so now that we set up the API endpoints and they seem to be working. Let's go to step number 4, which is to set up some rate limiting. I mean, once you got your API working, maybe you want to add a first layer of security. A good first layer of security tends to be just limiting the overall rate of requests. Should, your API get queried, maybe there's like a DOS attack or something similar going on. Or maybe you just want to make sure that if it's a low capacity service, it doesn't get saturated. So to do that, I have defined 2 files. Well, I've added a couple lines to the configuration files that I'm working with. First, there's the API gateway configuration file, which is basically my API gateway entry point. And over here, I have set up my rate limiting to be set at 1 request per second, which is very, very low. But I've set it just to make this demo work a little bit easier and make sure that I can actually show you what happens if it goes over the limit. And then if I go back here to my APIs, I have enabled that rate limiting setting within my F1 endpoints location. And I've set it to return a 429 error message, which is a too many requests error message if the rate limit is exceeded. So let's go ahead and deploy step number 4. And now let's go back to my driver's endpoint. And you can see if I query it multiple times a quick succession, I'll get my 49 error message. I'll get a helpful API error message, which is what I just set up in like step number 2, useful JSON error messages. And, if I was a user, this will actually tell me some useful information about my API. It will tell me that I should probably slow down my query rate. So we've got our endpoint set up. we've got some rate limiting going on. What if I now want to restrict access to my API? Maybe my API has some sensitive data, and I only want certain people that I know of to be able to query it. Well, there's two ways to do that. There's setting up API keys, and there's setting up child tokens. Well, there's actually more ways to do that, but those are like the two main ones you usually find in the API world. Now, since JOD authentication is NGINX Plus exclusive, I am actually going to show you how you can do either API keys or JOD tokens. And I'm first going to go over API keys, which is step 5. So basically what you need to do to set up API key authentication is first, you need to set up a map. The map includes basically some API keys, and those API keys are mapped to a specific client name, usually a client name that you will recognize. And by default, if no API key is presented, the API client name is empty or non-valid in this use case. Now, maps you will have to manually update if you're using a configuration management tool. That can be done relatively easily. If not, you can use the keyval store, but key value store that NGINX Plus has natively built into it. But again, that's an NGINX Plus feature and not an open source feature. If you're using NGINX open source, you have to use maps, find a way to update them dynamically. If you add more API keys, obviously, maybe you don't need to add more than like a couple API keys. And then I need to set up that API key validation within my Formula One endpoint. We can do that using the auth request directive, which points me to a hidden location called the validated API key. You see that it's hidden because it's using the internal keyword, which is NGINX's way of determining that an API is hidden or like not a public facing. And within this little location block, I'm doing some validation. If the API key is not presented, I'm returning a 401 unauthorized error. And if the API key is presented, but it's not part of the map, I'm returning a 403 forbidden error message because you're just sending me whatever API key that you randomly created. So now let's go ahead and deploy it. I am gonna fetch the command for that API key real quickly. Okay, so now let's check first that it's blocking my requests. If now you do a simple curl command like I did before, I get a unauthorized error message. And now let's use one of the API keys I did define as valid API keys. And voila, it works. Just for completion, let me just send a garbage API key and I should get a 403 forbidden error message. And there we go. So now let me touch upon how to do something similar using JOD tokens, which will be step 6. I think so. Should probably have used like actual proper names, but you know, instead of step numbers. I'm now gonna actually show you what's contained within those two files. So it's really necessary. It's just my token and the API secret. But I am gonna show you how you set up validation in this case. So first things first, similarly to the API key method, you need to define a map that tells you whether the JOD claim is valid or not. There's get head in this specific scenario. What this means is that get methods that use a JOT token are allowed, so were head methods or the options method. And by default, if the method does not match any of those methods, it depends on whether the claim in the API, in the JOT token, is an admin claim or not. Claim, should briefly mention, in case you don't know, that JOT claims are like a data form. It's like a little data you can put within your JOT token that identifies you as a specific user. It's basically a way of enabling role-based access to your endpoint, in addition to also enabling like some level of authorization into your API endpoint by virtue of the JOT token having a valid authentication token. So to set up JOT authentication, you use the auth JOT files within NGINX, within your NGINX conf. You need to point your key files directive to your API secret that I mentioned earlier. I was actually not going to share. And then if you go, in this case, for example, I'm going to enable some role-based authentication into my driver's endpoint, which means that I'm only going to let people query this endpoint if they're the method they're using is one of the permitted methods, which, as I recall, were get, head, or options. So if I try to do a post request to the driver's endpoint, it should fail. In the case of the seasons and the more generic endpoint, I'm not doing any further actual claim or role-based authentication. So as long as my JOT authentication token matches the private key in my JSON web key file, I will be allowed to go through. Let's go ahead and deploy it. Oh, step 6. NGINX is successfully reloaded. And let's first check that it is not working. For a while unauthorized, it's the same error message as the one I got with the API key. And we got the commands that I need to run because it turns out JOT authentication tokens are very long. Well, bearer tokens are very long. So if I use the right JSON web key, it works. I'm calling to driver's endpoint again using a get method. Guess should be noted that curl by default always does a get request if it's not specified within your request. And now, just to test what happens if I try to do an unauthorized method on my driver's endpoint, I'm going to try to delete some data. And indeed, as expected, I get a method not allowed error because I'm trying to do a method that's not allowed in that endpoint. Delete method. Now, step 7, I am going to skip. Step 7 was supposed to be JSON body validation using NGINX JavaScript. But I mean, if you want to look at it, it's in the GitHub repository. You can have a look, take it for a spin. But at the end of the day, I also want to cover NGINX App Protect. And it turns out that step 8, which is setting up NGINX App Protect, also does some JSON body validation to make sure that people don't try to send garbage data into your API, or potentially try to send some data that if you are, for example, interacting with a NoSQL database, maybe they could try to do like a NoSQL injection by sending some potentially harmful JSON data. Well, both JSON and NGINX JavaScript body validation and NGINX App Protect will help you with that. Oh, I forgot a command. Okay. So step 8, I have my Formula One Open API spec, which is just an Open API spec. Nothing fancy to see here. Then I've got my NGINX configuration file, in which I am now enabling NGINX App Protect, which is mentioned as an NGINX module. I am pointing my App Protect policy file to a policy file that I'm going to share in a little second. My policy file is where I'll be linking, well, it's where I will set NGINX App Protect to defend any, to basically parse the OpenAPI spec and only let through valid requests. And then I'm setting my security log. My security log directive, which means that I'll be able to see all my, I'll be able to see what requests are being done through App Protect by looking at the log file. Oh, step 8. Let me show you real quick the API security policy. This is App Protect's policy file. The most important thing here really is this little block here, in which I point my OpenAPI files parameter to point to the Formula One OpenAPI spec that I shared before. Let's deploy step number 8, which takes a little bit longer because App Protect it's a little bit longer to reload. Not that much longer, to be fair. And I go back to get the corresponding command to test it out. In this case, I am posting some garbage data using curl to my seasons endpoint, and NGINX App Protect should block that request. And indeed it did. It's telling me that it was forbidden. Doesn't let me access, doesn't let me send data to that endpoint because A, it's an invalid method for that endpoint, and B, the data I am sending to the API is actual garbage data. It's not in JSON format. It should not be allowed through. And finally, it returns a very handy, support ID message, support ID number if I want to track the number down the line, track the violation down the line. And I should be able to parse it real quickly here if I check the logs. Somewhere around here, there we go. So support ID, and it will tell me all the information I need about the blocked request. And with that being set up, that should be a pretty, I was going to say fully functional, maybe not a fully functional, but almost there. API gateway, or at least provides a building block to take your API gateways from here and further develop them and add more to them. Okay, so now let me go back to my slides. New share. Okay, there we go. That seems to be working. So now that we've gone over the demo, thankfully I did not have to go back to my backup sites, even though for a second there is some like it might have. We can, conclude this webinar by going over a little recap. So we have set up a simple NGINX API gateway that includes multiple routes, or 3 to be more specific, and endpoints, some rate limiting, some API keys, or advanced JOT authentication, kind of have to pick one or the other, and an API gateway that is proactively secured by NGINX App Protect WAF. And in doing so, we have become the ultimate NGINX API gateway hero. That being said, we have merely scratched the surface insofar as NGINX API gateway capabilities go. If you would like to find out more, you can find an API Gateway ebook under our library resources, as well as check out our comprehensive 3-part blog series covering how to set up more complex API gateways use cases using NGINX. And if you'd like to take NGINX for a spin, you can request the 30 days free trial for both NGINX Plus and NGINX App Protect at nginx.com/free trial request and see if it fits your API gateway needs and use cases. Thanks for joining. You can find my information right there if you want to reach out and have some further questions down the line. And there's now, I think, some time left for some Q&A, which, let's see. I see there's 2 questions. Let's go one at the same time. Okay, let's go with Ken's question first. Java is only signed and B64 encoded using JSON object sign encryption. Who says that's supported out of the box, or do I need a custom module? As far as I know, we just recently released some further. I mean, if you had asked me like 3 months ago, the answer would have been no for sure. We did just release with the latest NGINX Plus release some new JSON validation options. I am not sure that they actually work for HOSE use cases or if you need a custom module, but I can find out and get back to you hopefully within the next couple days. And there's Jeff's questions. Manually managing config files that does not seem extensible or administrable. Are there such tools for the enterprise? Yes. If you're using NGINX Plus, NGINX Plus has a built-in key value store that can be updated via a REST API. It's basically very simple to use. Again, there's just a few parameters that you need to pass, and the key value store can be updated. And the key value store basically acts like the map plug that I showed before. I didn't show it in action because the key value store actually we can only really read its values using the API, so there's no actual config files to see. It's just like a memory-based key value store. So yes, that will help with managing the API keys and any other NGINX config files. And then there's Brian's questions. Or API gateways typically managed by network engineers? Are there any UI interfaces for ease of management? So there's 2 questions there. The first part, API gateways typically managed by network engineers. To be honest, usually no. API gateways are very much, well, back when it was usually more of a DevOps kind of thing. DevOps people will manage these API gateways, or those API gateway developers. These days, you do find some actual roles that are only responsible for managing those APIs, more like API engineers. They're not that common, but they're on the rise. But in the essence of that, I'd say usually it's more of a DevOps responsibility. Second question, are there any graphical user interfaces for ease of management? Yes, we have a product called NGINX Controller. NGINX Controller is basically a graphical user interface product for NGINX. It lets you configure and deploy both application delivery use cases, or as I like to call them, web servers and load balancing use cases from a graphical user interface. And it also has an API management module. API management, which I did not touch upon in this webinar, and it's like the layer that will go on top of your API gateways. Similarly to how you can use API gateways to manage your API endpoints in a way. At some stage, maybe you'll end up having multiple API gateways, and that's when API management, or where API management comes into play. And well, yeah, NGINX controller has an API management module that will let you manage and deploy an API gateways the way you want. And sky's the limit, really. So with that being said, looks like there's no more questions. There's some chat. Okay, I see Jeff also asked that question on chat. That's replied. And yes, this localhost misspell. Good catch. Good catch that I did not catch. It happens. And I'll write down and make a note to reach out back to you, Ken, as soon as I can. All right. Well, if that is everything, I can stop my share. And I guess we can call it a day or a webinar. I'll stick around for the next 4 or 5 minutes in case anyone has any last minute questions. But I think we got it covered. All right, looks like we're actually gonna end up ending it. There's some, I share my data, my contact details before, but if not, if you access the GitHub repository, the slides when we send them out, if you happen to have any further questions down the line, just feel free to reach out. I tend to reply within a day or two, so probably get back to you soon if you have any questions. With that being said, have a great rest of your day, and take NGINX for a spin if you can.